All right, let's talk about slope and what we remember from our algebra class. So slope is a term that we use to discuss how steep a line is. The higher the number, the steeper the line is. Slope can be positive or negative. A line can have a slope of 0, or a line can have a slope that is undefined. We can find slope a couple different ways. We can find slope by drawing a slope triangle, or we could find slope by using the slope formula. We'll look at examples of the slope triangle and the slope formula in the next slide. So let's find the slope of these segments. Now, since these segments are graphed, it would be easiest to draw a slope triangle for each of these and look at rise over run. So as I draw the slope triangle on the first problem, I notice from left to right, it decreases. So my rise is going to be negative. And when I count from 3 down to -3, because the rise is given by my y coordinates, it's going to drop 6. And the run is going to go from -2 all the way over to 8. The run would be 10. So I'm going to turn that into a fraction and then simplify it to its lowest term. So I would do a -3/5. Looking at the second one, it's graphed, it's on a coordinate grid. So again, I'm just going to go ahead and draw that slope triangle, rise over run. Now I always like to start my slope triangle at the leftmost point and then go either up or down as my line goes, and I go kind of left to right on it. So I started at this point on the left and ended it at this point on the right. Then I just need to count what my rise and run are, or my change in y, change in x. So as I count this, I notice it goes up 6, and it looks like it goes over 5. So my rise over run in this case would be positive because it's increasing from left to right. And it would be a positive 6/5. So I think we're in a really good spot now to take a look at the slope formula, but let's do it using a problem that we've already done so we can check our answers. Now my slope formula is given by y2 minus y1 over x2 minus x1. Again, my rise, or my change in y, goes on the numerator of the fraction, and my denominator is the change in x. So as I look at these 2 points, it does not matter which one is x1, y1, and which one is x2, y2. So I'm going to go ahead and label the first one x1, y1, and the second one x2, y2. Then I'm going to plug it into my formula, taking note of these subtraction signs that are a part of my formula. So I'm going to do y2, that's -3, minus y1, which is 3, and then x2, which is 8, minus x1, which has a -2 there, so I'm going to be careful as I put that in, 8 minus -2. Now, as I simplify the top, I get a -6. 8 minus -2 is a positive 10. And I get -6/10 or -3/5, which is the same as the answer I already had. Let's take a look at one more using the slope formula. y2 minus y1 over x2 minus x1. If I want to find the slope of a line that passes through these 2 points, I'm first going to label them, and then I'm just going to go ahead and plug them into the formula. In for y2, I would put my -2 minus y1 is 5, x2 is 6, and x1 is 1. Simplifying that would be a -7 over 5. Now let's say, just for comparison's sake, that I switched around my x1, y1, x2, y2. Let me swap my ordered pair. I just want to show you that it doesn't matter which ordered pair you label as x2, y2, and x1, y1. Using this, based on my formula, I would do 5 minus the negative 2 and 1 minus 6. That would give me 7 over negative 5, which is the same thing as negative 7 over 5, or I could even put the negative in front. Either one of these answers would be acceptable for the slope of the line that passes through these 2 points.